Classes are similar to structs, but have more sophisticated functionality if you choose to use it. You can write a class that is exactly the same as a struct, so if you're storing just simple data with a few functions, it's up to you whether you want to use a struct or a class. Declaring a class looks similar to declaring a struct. So instead of struct and then your object name, you have class and then your object name. However, there is a difference. So right now we have a struct for our coordinate pair. If I run it, it works. And then if I change this to a class, then now I get a bunch of build errors. So why did this happen when we changed struct into class? It was because the data was no longer accessible to the outside world. Let's talk about accessibility for a moment. By default, structs have public member variables and functions. For classes, private member variables and functions are the default. Any private variables or functions are not accessible outside of the class. They are only available from within the class itself. We can take advantage of public and private members by hiding the inner workings of an object and only displaying the functionality of what the user, or another programmer, would need. More on the whys of this in another lecture. We can explicitly declare what is public and what is private with the public and private keywords inside of the class. It is generally a good idea to make member variables private and only make them accessible through a function in between. These are generally called getters and setters, or accessors and mutators. Keep this in mind for later. Another thing to keep in mind is the different ways you can create and define functions that are members of a class. While you can define your member functions from within the class, it is generally more standard in C++ to only declare the functions within the class. Then, we can define the member functions outside of the class. We do this because in C++, we store the declarations in one type of source file, the .hpp or header file, and the definitions in another type, the .cpp or source files. More about this on the lecture on using multiple files. So your class declaration should have member variable declarations and member function declarations, but not the function definitions. Remember that the definition is when we have the function body and the inner code. The declaration is only the function header, with a semicolon at the end. Also, notice that when we define the functions in this way, outside of the class, we need to prepend the class name, followed by the scope resolution operator, which is 2 colons. This is for functions that are members of a class, and not for just general functions as a whole that we've declared in the past. This is only scratching the surface of classes. There's still a lot to cover, but for now we should do some sample programs. Classes are very important, so make sure that you practice a lot. Let's start with a really simple class. So, if we had something like a chat log, we could have different line items. So let's say chat line. We can have string username, we could have string message, and then we could have something like the timestamp. But instead of declaring hour, minute, second, we could even create a little struct, timestamp. It will have hour, minute, second. Then we'll have a timestamp. So, let's say we want to initialize some stuff. So, we can have void, we could do setup. Let's just say set. And we'll have username, message, and hour, minute, second. I'm just going to name these shorthand for now. So username is equal to U, message is equal to M, and then time.h is equal to h, time.m, time.s. So, let's say we have a chat log or something, and there's maybe 10 lines of text. We can set these up. Lines I dot set. Let's say if I is even, we'll use one username, and if it's not, we'll use a different. So username, we'll just call, by default, we'll have Bob, and otherwise we'll have lol. So set username, we'll just say a message, this is a sample, and then we can set the hour, minute, second. So let's assume, let's just put 6, we'll use I as the minute, and we'll just use 0 as the second. So after all that's set up, we can output stuff. So for int I is 0, I is less than 10, I plus plus, I'm going to write a function that will just output this nicely, so void display. We'll want it to display the username, the colon, the message, but we also might want it to show the time. So let's say opening parentheses time.h colon time.m colon time.s, and then closing parentheses, and then we'll have the username and all that. So back down here, let's say lines I dot display. So right now all of the messages are going to be the same, but that's okay. Okay, what is this complaining? Oh, I'll just change that to MSG. And it's private because I forgot to set it to public. So here's a sample chat. Not the best looking thing, but that's just an example of how you could use a class and a struct. So for structs, usually I will just make them contain a small amount of data. Usually classes I'll use to do more sophisticated objects. Here's a program that we can use to multiply two fractions together. But really, this program is only good for this one program. It's not very reusable. So it can multiply these, but let's use classes instead to make it a little bit more manageable. So I'm going to create a class called fraction, and its private members are going to be the numerator and denominator. And then publicly, we'll want to be able to set it up. So numerator is equal to n, denominator is equal to d. So when we have this here, we can create fractions for 1 and 2 and product. Now we have the user inputting the values for the numerator and denominator, but we have to copy paste this message and do the same thing all over again and manually store it inside of the denominator and numerator. So instead, let's make something where the user will input it from the function, from the class itself. So for every fraction, it will use the same style. Enter a numerator and a denominator. So here, this is this numerator, this is this denominator. All we have to do is call this function, and it will prompt the user for this information, and we should be good there. So fraction 1 dot get user input, fraction 2 dot get user input. Okay, and our multiply fractions only takes all these integers right now. It's a little bit messy. Before I implement a multiplication, I'm also going to just have a display function, just to kind of simplify our output, so we don't have to keep writing it over and over. So they've entered their fraction 1 and fraction 2. We can say fraction 1 dot display and we can say x or times. Actually, I'm going to get rid of this ends line right here so we don't have to keep making everything on different lines. Fraction2 dot display. We can say equals, and we haven't calculated the value yet, but if we run this, it'll be asking for the first set, and then the program starts running down here. But now it's handling outputting the fractions for us. We don't have to worry about that anymore. Now we just need to make something to multiply these fractions. So in this function, because we can't return two values, we had to return the product numerator and denominator as references. So this ended up making our parameter list even longer and kind of hard to read. Now that we have a fraction, we can return a fraction type. We can just create something called multiply, and we'll pass in fraction 1 and fraction 2. Then we can create a temporary variable called product. We'll end up returning the product after we've done the calculations. And we can say product.setup. Now its numerator and denominator is going to be the product of these two numerators and denominators. But at the moment, we can't access those. These are both private, so we can't do this quite yet. We can do something to the extent of saying int get numerator and return the numerator, int get denominator, return denominator, and so now we can say 1.get numerator times 2.get numerator, 1.get denominator times 2.get denominator. Now that's also pretty long. How about we add a set function? So set numerator int value. Numerator is now equal to value. And void set denominator with some value. And denominator is equal to that value. So now instead of setting it up like this, we can just call a couple different functions. We'll have set the numerator of the product and set the denominator of the product. There. We're keeping these private. We're not making them public because we might want to change how something is implemented behind the scenes. Maybe for this fraction, we would still be using this the same way no matter what. There's not a whole lot of ways you could like change up a fraction, but if you have something more complex, like say a file loader or something that downloads content off a website or something similar, you might change the functionality behind the scenes, but you still want to give the user the same interface. So that's why it's good to have these public functions that is what they use. They don't access the behind the scenes data. Okay, so we have all this now. We basically just need to say product dot, well, we can set it. It is equal to multiply fraction 1 and fraction 2. And then we'll just display the product afterwards. So now we can get rid of all of this, manually outputting the fractions, manually formatting them, manually setting their different values. Okay, I created a syntax error. And then we can run it again. So we have this. It might not look a whole lot simpler at this point, but it is much more maintainable, and we can reuse this fraction. We can save it in its own file, so I'll just create a fraction object.hpp. Normally I wouldn't name it fraction object, I would just name it fraction, but I named the source file that contains the fraction, the main function. I named it fractions, so I'm going to cut this. I'm going to put it in here. And then instead we can say include fraction object. We don't need this one anymore. So that's cleaned that up quite a bit. There's one thing I have to add here. and we'll explain this in a future lecture. If not defined fraction, we're going to define the fraction. And if. This is basically a way to make sure this file does not get included in the program multiple times, because if we keep including this file in from different files, we will get an error saying fraction has been declared multiple times. And we'll go over this later, but whenever you create a HPP source file, you'll need to have this. Okay, here's another program that we can convert to use classes. So if I run this, basically it'll tell me HP for player 1 and 2. Player 1 can choose to have an offensive attack or defensive attack. Same for player 2. And then their health is taken away from. So we have player 1 name, player 2 name, player 1 HP, player 2 HP. And then as long as someone has more than 0 HP, as long as both of them have more than 0 HP, the game will continue looping. It'll output their HP. It has variables for their choices, attacks, and defense. And then it has this pretty identical looking code where the player 1 chooses a turn and it sets their attack and defense, and same for the player 2, and then it subtracts from their health. So it's a lot of duplicate code, just a little bit different. Different sets of variables, but the same thing. Players both have names, HP, they make a choice, they have attack and defense. So it doesn't make much sense to write it like this. This is just kind of a mess. So let's create a class of player. We'll move all these variables, so we'll have string name, int HP, and we can even have int attack, int defense. Okay, so when we create our player, we'll want to create a setup function. So we can set the name and set the starting HP. So this name is equal to name, this HP is equal to HP. Remember that because I named these two parameters the same as member variables, there's a naming conflict, so we have to specify this arrow name means this one. Name here means the parameter. This HP is the member variable, and that one is part of the parameter. Okay, so now instead we can say player, and we can just make two players. Let's make it an array of size 2. So we can say for each of these, players p dot setup. Well, we don't really want the setup here like that because we want to give them unique names. So we'll have player 1, which is index 0, and set their HP to 100, and then player 2 for the next one. And we'll keep this around. We just don't need it right now. Okay, so we can erase this. We've basically done that. We can't access these members directly, so let's just have a boolean is alive, and if HP is greater than 0, we're going to return true. Otherwise we'll return false. We can actually shorten this up by saying return whether HP is greater than 0. This will either be true or false, and we can return that value. So while players 0 dot is alive, or and players 1 dot is alive, while they're both alive, we'll do that. Okay, so we also don't have a way to get their HP, we just have a way to get whether they're alive. So let's create int get HP, and we'll just return the HP value. So at the beginning of the round, let's have this. We'll uncomment it out. Oops. And we can't get their name either, so let's do that too. string get name, return name, and say players p dot get name, and we'll output their HP. Players p dot get HP. Let's do a tab. Then we can put an inline here. Okay, so we have all of this stuff, and it's pretty much redundant. Let's create a function that lets the user choose a choice. So we can erase that for now. We'll have both turns, but we can have a function like, let's see, int choose action. We'll output these two things. We'll create a choice integer. We'll have them input it and return the value. So down here we'll have another for loop. So this is going to be player 1's turn the first time through. So let's say player p.getName turn. So int choice equals choose action. It'll call that, display the options, and it'll come back here. And we can say if choice is 1. Down here we have changing attack to 1, or attack 1 to 10 and 2. So if choice is 1, else if choice is 2. And instead of having to specify, let's create another function where we can set the attack and defense. So void set attack and defense. We want to pass in some values, int attack, int defense. This attack is attack. This defense is defense. And then we'll call that down here. So if choice is 1, for this player we'll set the attack and defense 10 and 2. Otherwise we'll set it to 5 and 5. Then I can essentially erase this. Finally, the player's HP is affected by what the attack amount was and the defense that the player has. So this is the opposing player's attack value and the player being attacked, their defense. So let's have get attack, and that will give us the attack value. We can also say void take damage, int amount. So with this, we'll pass in the attack value, and then we'll subtract the HP, but also take into account our defense. So HP subtract amount minus defense. Or we can even calculate the damage ahead of time. So let's say float damage is equal to this. We'll say see out name hit for that amount of damage. Okay. So first player 1 is attacked and then player 2 is attacked. I'm going to put another loop so both of them get to choose their options first. Then we'll do the attacks. Players p dot, let's see, take damage. Players, well, okay. Let's not have this for loop here. Erase that. 0 take damage. Players 1 dot get attack. And vice versa. And we can erase that. Now we can build. Let's see, I did not put a semicolon there. But now we can run offensive, defensive. And it's basically handled for us. And we can make little tweaks if we wanted. Like, so if we wanted to change this message, we could change that. If we wanted to change how the name was returned, we can change that as well. But that's basically how we can use one class, reuse all this information, and make it a lot more reusable and extendable. so we could keep adding on as we wanted.